Today we're going to be talking about how to solve derivatives using the chain rule. Chain rule is a method of solving derivatives of composition functions. It's given by f of x equals f of g of x. And we're taking the derivative of x prime g of x multiplied by g of x. So this is the derivative of our outer function, and then the derivative of our inner function. And with this, we can take derivatives of something like sine x squared or sine cosine x squared, where we have outer more inner than the innest function, or something even like this as well is possible of what we can solve. Another way that chain rule is commonly denoted is as the following. Again, we got inner, outer, outer, then inner. Du multiplied by du over dx, and then u is going to equal our inner function. However, it's normally most common to be using this method as a little easier to digest and to understand. So we'll start with an example. Y equals sine 3x plus 2. So dividing our functions first. Outer, inner. So this will be our fx g of x. So starting, let's go with our inner first. Our outer first. So our derivative of y prime is going to equal cosine 3x squared multiply the derivative of our inner, which is going to be 3. So comparing this back, so we have f prime g of x multiplied by g of x. So these are where these line up at. Similarly, if we did y equals cosine sine x, take a derivative of our outer first, so you have negative sine x, and then the derivative of our inside cosine x. There's always going to be a pattern in all these examples. It's just important to keep track of which one is your inner function and which one is your outer function. Okay, let's do an example with exponential functions. Of x cubed minus 2x. There's many ways to solve this one, however we're going to use chain rule for this one. So using our bottom definition, so we had y is going to be equal to g of x. So in this case, x cubed minus 2x is going to equal 3x squared minus 2. And since we set u equal to the inner function, we have y equals e of u. Taking the derivative of that, it's going to just equal e of u again, plugging everything back in. So now we're going to do dy u multiplied by dy x e x cubed minus 2x 3x squared minus 2. So you may be asking, where did this part come from? I thought our function was e of u, but we need to plug this u back into our original function or to get the derivative of what our initial question is asking. Next question we're going to do, logarithmic, natural log 5x cubed plus 4. So the natural definition of a derivative, a natural log, is going to equal 1 over f of x multiplied by f of x. So we can't do it that method. And I'm going to show that it's going to equal the same thing. So you have 1 over 5x cubed plus 4 by 15x squared plus 0. So according to the definition, this is what our derivative will be. But if we're going to do it with chain rule, let's move this over. Let's say u equal to 5x cubed plus 4. Our derivative of this, so u prime equals 15x squared plus 0, which we have in the other example, which means we're in the right direction. And then the derivative, now we got our x function of natural log of u. It's going to equal 1 over u. So now we can plug everything back in, plug this u back in over here, and multiply them together with our 15x squared. Get 15x squared over 5x cubed plus 4. And then, again, these are the same answer, proving that our chain rule was correct. Next question we're going to do might be a little tricky one if you're not paying attention, but we need to pay attention on all our exponents that we have in the question. 3x to the 5th. So we'll start with our outer function, and then move our way into inner after. So starting with this one, this 5 is going to move back here. 5, 4x squared plus 3. The inner is going to stay the same for now. Now we're going to take that derivative of the inner function. We can simplify this more to 40x 4x squared plus 3x. And I just got that multiplying this 5 by this 8x. Next question we're going to do similar. (3x fourth minus 2x). So this equals, we can take that square root out and make it into an exponent. So let's move this over here, taking the derivative of the outside, just leaving the inside for now, then taking the derivative of the outside. Okay. So let's do another example where we can have multiple chain rules involved. So the method's all going to be the same. We're going to start with our outside function first. Then we're going to go with our next inner function. Then our next inner function, that's going to be our solution. And if we were to have a exponent on the outside, we would take this one first, this one, this third, and then fourth in that step. So always be working from outer into inner. So we can do one more. So how are we going to start this one? So first, let's identify outer to inner. So we have outer, inner, inner, inner. And whenever you have a 5 at this location, we can actually move that to the end. Put that on the outside. So we can call this sine, tangent, cosine, cube, fifth. So let's take this derivative first, starting with our outside. 5 sine tangent cosine x cubed fourth. And then let's move down. My next line is going to be my next derivative. So you guys can better see which line that I'm taking the derivative on. So next one, we're taking the derivative of tangent. Or sorry, taking the derivative of sine. So now we're going to have cosine tangent cosine cubed. Okay, next line. Now we're going to be taking the derivative of tangent. Derivative of tangent is secant squared. Now for cosine, negative sine x cubed. Now for the last one again, x squared, we'll have 3x squared. So you put those all together, and that will be your answer. As for a challenge question for the last, and the answer will be in the description below. Thanks for watching. Please hit that subscribe button, like button.